All right, let's jump right in. Think of this as your ultimate cram session for the big AI final exam. We're going to hit all the key concepts, the stuff you absolutely cannot afford to forget. Yep, this is our cram session. No fluff, zero wasted time. We are diving straight into the bedrock of AI, the core info you need to really nail this. Ready? Let's go.
Okay, first things first, we have to tackle the core definitions. And I mean, this is probably the most critical part, right? It's a hierarchy where each idea builds on the one before it. If you get this down, trust me, everything else will just click into place.
So at the very top of the pyramid, you've got artificial intelligence, AI. Just think of it as the giant umbrella term. It covers any system designed to mimic human intelligence. You know, things like understanding what we say, recognizing a face in a photo, or making a complex decision. If it acts smart, it's under the AI umbrella. It's the whole shebang. Okay, so let's zoom in a bit. Tucked inside that big AI umbrella is machine learning, or ML. This is really the engine that powers most of the AI you see today. Here's the key difference. Instead of a programmer writing a million lines of code for every single possibility, machine learning lets the computer learn for itself just by looking at data. It's all about finding patterns so the system can get smarter over time. And we can go even deeper. Inside machine learning, there's a really powerful technique called deep learning. Now, this is where things get cool. It uses something called neural networks, which are, kind of modeled after the connections in our own brains. This structure lets it tackle super complex patterns. Think about understanding the nuances in your voice, or recognizing a specific object in a messy photo. That's deep learning territory.
And that brings us to the cutting edge, generative AI. This is a special kind of deep learning. Its whole job isn't just to understand or sort information. Its job is to create something new, something original. We're talking about AI that can write an email, compose a song, or dream up an image from scratch. That's generative AI.
Oh, and we can't move on without mentioning a super important related field, natural language processing, or NLP. This is the magic that lets us talk to AI. It's all about enabling machines to understand, generate, and just interact with human language. NLP is the bridge that connects our world to the world of the algorithm. Okay, so we've got the what, we know the definitions. But what about the how? How do these things actually learn? It all boils down to a fundamental two-stage process that you have got to know. It's called training and inference. It's actually pretty simple when you think about it. First comes training. This is the homework, the study phase. You feed the model tons and tons of data, and it just grinds away, learning all the patterns and connections. Then comes inference. That's the test. It's when the model takes everything it learned and applies it to new data it's never seen before to make a prediction. So you study, and then you perform. Simple as that. All right, so we know models learn through training and inference. But how they're trained? Well, that's a whole other story. There are 5 main ways, and it's best to think of them as different tools in a problem-solving toolkit. You wouldn't use a hammer to turn a screw, right? Same idea. And yeah, to stick with our exam theme, it's like your test has 5 totally different kinds of questions. You've got multiple choice, you've got essays, you've got fill in the blanks. You need a different strategy for each one. That's exactly what these 5 learning types are. Different strategies for different AI challenges. First up, we have supervised learning. The key word here is labeled. All the data is labeled. It's basically like studying for a test with the official answer key right in front of you. You show the model a picture of a cat and say, this is a cat. Then you show it a picture of a dog and say, this is a dog. You use this when you know exactly what you're looking for and you can provide those right answers for the model to learn from. Then you have the total opposite, unsupervised learning. Here, there are no labels, no answer key. You just dump a whole bunch of data on the model and say, go figure it out. Its job is to find hidden patterns and group things together on its own. This is perfect for when you're not trying to predict a known answer, but you want to discover something new, like finding different groups of customers in your sales data. Okay, now this next one is really clever. It's called self-supervised learning. It starts with unlabeled data, just like unsupervised, but here's the trick. The model makes its own practice questions. For instance, it'll take a sentence, erase a word, and then its goal is to guess the missing word. It's basically teaching itself the structure of the language. This is a total game changer for things like autocomplete, where you have mountains of text data, but no one to label at all. Now, let's be realistic. In the real world, you rarely have perfectly labeled data or a complete free-for-all. Often, you have a little bit of labeled data and a ton of unlabeled data. And that's where semi-supervised learning shines. It's the practical, middle ground approach. It uses those few labeled examples as clues or hints to help it make sense of the giant pile of unlabeled stuff. Super efficient.
Last but not least, we have reinforcement learning. The best way to think about this one is learning by playing a game. The model or agent takes actions in an environment, and it gets points, rewards for good moves, and loses points, penalties for bad ones. Over millions of tries, it learns the best strategy to maximize its score. This is huge for things like training a robot to walk or building a recommendation system that learns what you like. Okay, deep breath. We've covered the definitions, we've covered the 5 ways models learn. You're doing great. But there is one final, crucial concept, a major trap you need to avoid. I call it the Goldilocks principle, because when it comes to model performance, you have to get it just right.
See, a model can mess up in 2 big ways. The first is underfitting. This is pretty simple. It's like you didn't study enough. The model is too basic, it missed the main ideas, and its performance is just bad. Then there's the other extreme, overfitting. This is sneakier. This is like you memorize the entire textbook word for word, even the printing errors. You can ace a test on that specific book. But if you get a question you haven't seen before, you're toast. The model learned the training data too well, including all the random noise, and it completely fails when it sees something new.
So what's the takeaway? The goal, the A+ answer, is to find that Goldilocks sweet spot right in the middle. You want a model that's smart enough to learn the real important patterns, but not so obsessed that it memorizes the meaningless noise. And that ability to perform well on new, fresh data, that's a key term, generalization. That is the true test of a great model.
All right, you ready for the bonus round? This is the advanced stuff, the concepts that are really shaping AI right now. We're talking about 2 massive ideas, foundation models and, of course, large language models. So what on earth is a foundation model? Imagine an enormous model pre-trained on a staggering amount of data from like a huge chunk of the internet. It's like building a universal encyclopedia of human knowledge. But here's the magic. This giant general-purpose brain can then be tweaked and specialized for all sorts of different jobs. And that process of specializing it, that's called fine-tuning. It's a 2-step dance. Step 1, build the massive general foundation model. Step 2, take that model and train it just a tiny bit more on a small, specific data set for whatever you need it to do. It's like taking a brilliant person who knows everything about everything and then sending them to medical school to become a heart surgeon. You're turning a generalist into a specialist. And I bet you've heard of large language models, right? LLMs? Well, now you know exactly where they fit in. An LLM is just a type of foundation model that specializes in, well, language. They are the absolute experts at understanding and generating human language. They're the engines behind the tools that generate text, translate on the fly, summarize long documents, all of that stuff. And that's a wrap. Our cram session is done. Let's just quickly check our notes. Core definitions? Check. Training versus inference? Check. The 5 learning types? Double check. Getting the fit right and avoiding overfitting? Nailed it. And foundation models? Absolutely. We've covered all the essentials. You're ready.
So, the last question I have, it's not on my imaginary exam. It's for you. You now have the playbook, the fundamental concepts for understanding AI. The real test, the fun part, starts right now. So, what are you going to do with it? What problem will you solve first?